Hi, thank you for interest in Cloudscape Seasons. I'm providing you with few slides here, and after you can jump ahead and see the hands-on section. This technical information is very important and explain a lot why some things have the visual they have, like the cloud types, informations, what you can do. So make sure you read the technical material at the beginning. The hands-on section will begin when the video marks 16 minutes. Welcome to our hands-on section. So from the point where you create a project in Unreal and you add the asset from the marketplace, you see at the bottom you have the Cloudscape Seasons folder and the maps folder. So you will open one of the demo maps. Takes a while because I have created the largest uh, simple landscape you can do. So it's quite large, so you can see how the performance from the cloudscapes affects the entire space with this huge landscape. So there you go, you see the clouds moving. Okay. Now you put in simulation. And you go to a fly through. For those who wants to make a flying simulator or spaceships going through the clouds or whatever, uh, try to make uh, dislocation speed quite realistic, because as fast as you go into the cloud direction, you can see some artifacts. There is a way to eliminate these artifacts, but it affects performance. So the good point is, as closest to the cloud as you are, if you increase the ray march steps, instead of having impact on performance, uh, you can get quite good results. Here you are changing the layer 2. It is these clouds you are seeing. You are changing the altitude for those clouds, and we almost have a fog here. So you can play like that. But the volumetric solution from the engine is better than this and less costly. There you go. The clouds are now very low near the ground. Now I'm changing the coverage scale, and you can see almost no clouds. Float a bit more. And the changes in these values can be quite low and have a great effect. So you can play with them very smoothly and see great results. These are the values for the coverage scale. So the scale tells how large the clouds are. And just for this particular layer. and the coverage value, you put as much clouds in the space until you have all the sky filled with cloud. Now I'm going to the edge. You see that even having a big landscape like this, the clouds are over it. You can see on the ground the shadows, and this is the cube where the clouds are generated by ray marshing. So see, the green part there is the landscape. The base of the cube matches the landscape altitude. So basically you are inside the cube. And this is great because it helps to have better performance, because you are only seeing part of the cube. So you have like a culling effect. So there are several values here. Like you have jitter, you can use as you move through the clouds and diminish the artifact. Several values you use curves to drive it in based on the sun position, and others from the moon position. Now I turn off layer 2 and turning on layer 1. Layer 1 is set with a different set of clouds. They are more massive. You see if I change the coverage, the shapes are different. I can turn on both, and this is good because you can have different kind of shapes that usually you want. So you can have up to 3 layers. Each layers you can have clouds in different or same altitude. Your choice. You can compose several shapes. Otherwise it would be hard to do with just one layer. Later on you'll see a picture where the clouds are just like this. Changing the coverage here. Back to the ground. Check this now. I'm changing the density, so the clouds, because you are increasing the density, they became more dark, and the sharpness, it is use a power effect on the density, so you have small clouds. And the opacity, you also diminish the density, still keeping the size and coverage for the clouds, so they look quite smooth. And that's another effect you can use and combining the layers. Also you have this the sun and this scattering effect for the light. You can change it here, and when you use negative values you are likely creating a halo. Here you change the intensity in the alpha channel for the sun color. Okay, and you see when you go far there is less scattering. That's because I call it your halo. If you use positive values, the scattering is more uniform. See? You have a curve that you can drive on a different occasion if you want. Now we are going back to our default 3D person map, and I will strip this stuff just to let the things we need. So picking just the stuff we don't need. And the walls and far. Boom. Well, what you see here is mostly caused by the atmospheric fog. Okay. You let the fog turn it off for now. Still enabled and visible if you play. So you go to blueprints and we have here Sky Seasons. It is a sky sphere blueprint similar to the one it comes with the engine. And let's change it here for sunlight, so easier name, and duplicate it to have the moonlight. Like so. And you set here in the sky season. Now immediately the blueprint starts to draw the sun and the colors for the horizon, the zenith. I still have the old clouds because you can still, depending on the game settings, use the simple clouds instead of using the volumetric one. Setting the moon. You can choose full moon. It's quite nice to see. And here I have a place to put the moon blueprint. And we also have a sun blueprint. And wind seasons. This blueprint is to tell the strength in the direction the wind is blowing. And as we have 3 layers, you can have different direction and strength for each layer. Now the Cloudscape Seasons, start to draw in the clouds. And you're just trying to look for the places for the wind up here. So each layer, each wind speed. And down there is a place for the sun and moon and the sky attributes. So here we try to find the sunlight here. And down there, moonlight section here. Let's turn off this and place this one because it's cool. So you create a landscape here. So you see the demo maps use the maximum values you can place here, but we will create a small one because it takes long. There you go. And we get some amount of here of objects to build light because you have the components here, and we have 2 directional lines. So if you are not creating a static shot, but like you are wanting a game where the sun and the moon will move, you have to choose a movable light, not a stationary, not a static. And in this case you don't have lights to build unless you have other types of light. And the sun here is quite shabby. It's because we don't have balloons set, so you set the new balloon, the convolution one, and you have a nice balloon. In the kernel here you have to show the engine content, and then you have like so. Yeah, we leave the moon invisible because the blueprint will take care of the visibility. And Sky Seasons, you can change the sun brightening. And the directional light, you can leave the value high enough to have the shadow effects you need on the static meshes, and if you want to set the light color, so you can have the shadows affected by this. There you go. Every time you change the directional light position, you have to refresh the blueprints. Right here, I'm trying to make a sunrise or a sunset effect. So we place the sun a little about lower until you have the horizon color changed by the blueprint. There you go. And the same for Cloudscape Seasons. Now see that it's for some position, the anisotropic value, it's not enough to put that halo, so I have to change it here, like so. You see, then you see that this, as soon as you have curve values to change the look for the anisotrope, you also have the overall color. You can change it here, so you can make the clouds darker or not. The ray marsh stats, you can like enhance the details, but it's costly. Shadows, you can change the density, and also you can change the spreading, like here. And light shift, it's like making the light coming from a small deviation from the current position. Extinction color is how the color here. See that as we are changing the values, the engine is allocation memory and not releasing. Soon it will crash. So if you play and a little bit, you possess the pound, you see that the memory is released. Then you can play again. If you like move like this the colors, immediately you see a lot of memory being allocated. So you have to, like, instead of dragging, just click. Now we have some orange color. And that's how extinction works. Let's play again. Possess. Now it's better. The remaining parameters are for the shadows in the ground. And the sunlight color changes the ring effect color. You can also tell how much the sunlight will be displayed on the clouds. And the ambient lighting is each color you have reflected from the environment to the clouds. Usually in GI, sky color will do this, but as we have to fake it for the ray marsh code, we have a different value to change for this. Now, turn off the volumetric fog visibility, because if you change the color here, barely affects the result. So, see, almost no change. So, turn off. Also, the new volumetric fog, I think, came is on 415. This is way better to use as fog, and is compact with the Cloudscape Seasons. And you have to refresh wherever you change the light direction. Let's see. Okay. In this part of the video, I just forgot to put the moon direction in the correct position, so you can't see the moon, but it's possible even without the blueprint. And I'm placing here both sun and moon blueprints along with the calendar. Calendar you can change to have both sun and moon trajectory calculated by latitude and longitude. And the trajectory I calculated in their blueprints. You always have to refresh to see results. And we have to set the moon down here in the sky seasons. And the calendar, you can have the time running automatically, so you can see the time it goes by. And Cloudscape, you have to refresh too. We have these colors because we changed them in the blueprint, so we have to move them to the original default values, like here, here, and here. All this because we are not using the curves to drive these values based on the sun and moon positions. Now you can see how you can achieve any kind of color and if you have to affect the shadow color, you have to use distinction. Okay. And remember to free this memory, otherwise crash you have. This only happens on the editor, will not happen if you have a game made with the system and compiled. So as we are having high resolution for the coverage, we have a lot of memory, and each value we change makes another copy and another copy. Now you have the moon, quite big. Like so. can change the size here and the brightness. No stars because they are set but not lighten enough. You can place a higher value until you see them like so. Not too much. So basically we cover it. For the simple sky. Now I have to add some more information because some values will have different results regarding the performance. So whenever you see attributes in this Cloudscape for density, ray marsh, cloud self-shadow, and turbulence, you have to look at them carefully because they have different impact on the performance. So I have here a text telling you what they are. We do now a more complex sky. This one you have basically the calendar driving the values for the date and hour. So this part is realistic because as the time changes, the sun and the moon position changes. So their trajectory changes. In the case of the moon, you have the phases. It will change also. Now you can see the moon being driven because now the time is passing faster. And it is disappearing as they are going through the horizon, and the sun will rise according to the longitude and latitude you have chosen in the calendar. So now you have the sun rising. If you ever need to drive the sun, I think the time fast as this, try to select values where it matches other events, like the palm is moving normally, so it makes no sense the time passing that fast and the palm is still with the slow movement. Well, the system is not just a system with ready-to-use clouds. You can change their shapes. You can say where you don't want them. You can also change the appearance, like the minimum details, the overall shape. So there is, like, this material is where you define where there are clouds into the 3D space. So you have basically the flipbook here, and these three textures, each one is one layer, and I add them to make it the final composition. Each one of these are generated by their own materials, these three one. So we have one for mid clouds, low and high altitude, and we will create instances for them. And place them here. So this starts to give you freedom, artistically speaking. This place down here is where I model the cloud features. So for low altitude, I have this for the cumulus, this for the stratus, this for the cumulus stratus, and the stratocumulus. You can enable each one if or multiple of them. It's about the same material, but I have, in this case, two clouds. They are different, so different values, but they are done. You don't have to worry like each position that type of cloud have to be modeled. You already have them, but we still can change in the instance because the cube is quite large. Sometimes you need even larger, but a larger cube means more altitude, but your ground is still the same. So you might want to bring them down sometimes. This text is then one you have the freedom to choose where to show or not the cloud. You can also use it to change the shape. And then those three textures, you place them here, here, okay, and layer 3 here. So I have prepared one material. It can be any material where you can design shapes that you describe how to mask those clouds. And this pseudo-volume texturing encoder is the one it will generate the flip hook. So it generates the UV coordinates for the amount of frames you want. You have to change something and save it here, otherwise you're not displaying in the preview. These noisy materials, they usually takes a long to compile. That's why it's taking so long. But this one is set to generate Voronoi masks, so I can have round shapes. Now, this is what you get. So those black balls, they are in 3D because the volumetric and the ray marching will multiply those black balls, generating empty areas. And the funny is, if you invert, you will have only clouds where the now inverted the spheres. Now this is a very simple blueprint to render some render target. You click in bake and you have it. You can save as texture and select. You see that they are 4K, and my advice is to use the same resolution as for the weather coverage, like so. Now, if you see, the shapes are now different because there is a lot of black spots that we don't want cloud. And this is how you can control artistically on top of the procedural part of the system. And you could have 3 different textures because you can have up to 3 layers. So each layer you can control differently or use the same textures. Now what they are doing is selecting the inversion on this instance. And now where you have black spheres, you start to have white spheres, and where it is white, you have black. So instead of telling whether you not have clouds, I'm telling now how the clouds will have its final shapes. There you go. Let's pick that and create another texture. There. Save this. Again, something totally different. You can even see the rounding clouds at a distance. Well, we can also change the appearance of the texture. It tells where you have high and low areas in the clouds. It is used for the details. So you have base text, so this is the blueprint. It will show the textures for us. So the Blaze Cloud material is one. The details, they are pretty small. And the turbulence one, usually turbulence size will be the same as the weather coverage. And this one is for the material. It should be applied in the cubes to show the textures. You can change them, but it's not necessary. I kept the names so it's easy to put them. After this, all you have to do is make it visible. Okay. Each channel, RGB, and in the case of the cloud base, I included the alpha. You have a load scheme. So closest will be in the R channel. I even further the G channel, and in the B and A even further. I use the last box to show how they are interpolated, so you can figure how might be the appearance in the part when they mix, but it's just for reference. So white will mean the height spot, and the dark will be the lowest spot. And the details gets a small portion of the basic texture. So if you make the basic texture 256, you can like take the details 164, you'll be a quart. So you can work the overall look and the small detail. The Raymar shader will interpolate it then, and you can see real time as soon as you change the instance material. Like so this will be placed for the entire cube, so you can have nice base cloud with lower numbers. Understand that bigger the texture, more time and more memory you need during gameplay. This affects performance, but the worst case is you will start to fill up all the video card memory on top of whatever texture you have already in your props and so forth. This base and details texture, they are quite complicated and uses a lot of noise nodes and takes several minutes to compile. So change them wisely. You can make your own, but this one it gives the best result. It's really endless the deep details you can have here. So see this noise appearing. It has to be with the speed you are advancing in the cloud direction. One way to get rid of this is increasing the ray march steps. See the noise there. Now we increase, and now you don't see anymore. You needed to find the best step value according to the velocity you are going to the cloud direction, so you not see these artifacts. You can use jitter, so you keep the performance and get rid of the artifacts also. I prefer work with the steps instead of jitter. Why that? Because with transparent materials against the sky, jitter might produce other types of artifacts. So you have to pay attention to this and model accordingly. You can also play with the density, sharpness, and opacity values. Density, you can increase the look and the volume size for the cloud's sharpness. You reduce the shadows a bit and the cloud sizes, while opacity will keep the sizes and make the clouds lighter until they disappear. They look like small smoke. This we're applying that texture we made before, and you can see the effect here. For the mask, you also have density level, sharpness, and opacity, so you can play with those as well. And again, getting more looks. The main reason why I have placed those real cloud pictures is for you to have a reference and do not exaggerate on the appearance when you are modeling. So you have the artistic freedom, use the procedural generation, so you have dynamic clouds, but you still have to be in mind what they look like in the real nature. Like, you can't expect with just few small clouds you'll be able to see rain. So if you have to place rain someday in your game, you not do it with small clouds. You really need large clouds, and it takes almost all the space. Here you can see the external part of our cube. One thing that I have provided is the ability to move the cube. So if you have a very large terrain and you need your character to move to the edge of this terrain, you can move the cube along with the character and keep drawing clouds wherever the cube is, respecting the seamlessness between the texture used here. The coverage noise, it is seamless, so moving the cube, you have a seamless transition between a portion where the cube is and where it will be. See, I'm moving the blueprint. It is also moves the cube, the mesh for the cube, and you see that the clouds, new clouds appear. The simulation is accelerated, of course, because you have turbulence and the winds, and they move along with the clouds. So, and I'm using here really big values. Once inside the cube, you can see that the clouds remain the same if you are standing still. See, I move the cube beyond the terrain, so you can have a composite terrain and move the cube along with your share, and you still have the clouds drawn. Always remember to have the location for the blueprint set to 0 when you have completely draw your level. See? You're having a shadow project on top of us. Now you have a smooth transition. I have provided us a divisor so you can change the scale of this movement according to the max speed your character can run, because sometimes you are just walking, sometimes you are running, sometimes you are inside a vehicle, and they have different speeds. Remember every time to see how much memory you are using, or it crashes and you may lose your work. You only have to worry while you are changing the values for the main blueprint. Again, these values are huge. But it shows that there is coherence for the clouds generate. So this I'm explaining about the sizes for the textures. Always remember, bigger the texture, more memory, use it on the video card. I hope you guys have enjoyed this, and good luck in doing. Take your time to comment on the video and comment on the product page and the support thread also. If you need more demos and explain any other attribute, feel free to post. Thanks again.